Alright, this is lesson 2.2 of stretching and shrinking. Today we are going to look at what the scale factor is. So we're going to know how to calculate the scale factor of two shapes. To show that, we are going to calculate the scale factor for rectangles and triangles. So let's go ahead and get started. Okay, calculating scale factor. First I'm going to show the equation. Scale factor equals the new shape over the old shape. Now, when a fraction can also be division, so new divided by old, if you want to think about it that way. In the equation written out in words, the scale factor equals a side on the new shape divided by a corresponding side on the original shape. Corresponding is very, very, very important. If it is not corresponding, you are not finding a scale factor. And you also need to start with the new shape divide the original shape. If you want to go so far as to set up your division, the new shape goes inside the box, the old shape goes outside the box. Alright, let's go ahead and get started with some examples. So, calculate the scale factor. Number 1, divide to find the scale factor. So first we have to figure out what our corresponding sides are. Remember, corresponding means it's in the same part of the shape. So this side with a 1 is corresponding to the side with a 2. The side with the 4 is corresponding to the side with the 8. So, let's set up our division. We can choose either one. First, we have to pick the new side. I'm going to pick the 2. The original divided by 1. 1 goes into 2, 2 times. 2 is our answer. 2 is our scale factor, but let's double check that by using the other side length. Let me try the 8. 8 divided by the original, which is 4. 4 goes into 8 twice. 2 times 4 is 8. Subtract, we get 0. Answer's 2 again. Doesn't matter which pair of corresponding sides you choose, you're going to get the same scale factor as long as you're doing it correctly. Alright, number 2. Once again, divide to find the scale factor. Well, this triangle is going to be easy because it's 2, matches with 5, but it also matches with 2, which matches with 5, which matches with 2, which matches with 5. So as long as you can do your division, you're not going to mess this one up. Pick one of these 5s, goes inside the box, divided by one of these 2s. 2 goes into 5 2 times. 2 times 2 is 4. Subtract, we have one remainder. We don't use remainders anymore. When you have a remainder, you add a dot 0. Bring that down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract, we have nothing left. Decimal goes in your answer. Our answer is a scale factor of 2.5. Okay, not too hard. We can't really double check that with the others because all of these are going to be 5 divided by 2. 5 divided by 2. 5 divided by 2. Now, let's look at what the scale factor actually means. So, on number 1, the scale factor is 2. What that means is the original shape times 2. 1 times 2 is 2. 4 times 2 is 8. 2 times 2.5 is 5. 2 times 2.5 is 5. And 2 times 2.5 is 5. It's the original shape times this number equals the new shape. Alright, new examples. Divide to find the scale factor. Now, this one attempts to trick you a little bit, so let's figure out what our corresponding sides are. The longest side of the triangle matches with the longest side of that triangle. That's the simplest way to do it. Shortest side matches with the shortest side. Notice that's on the bottom, that's on the left. It doesn't matter. If it's the shortest side of the triangle, it matches with the shortest side. And then the side in the middle matches with the side in the middle. So we have 3 different divisions we can do. I'm going to set each one of them up. So I have 9 divided by 3. 9 on the inside, 3 on the outside. 6 divided by 2. 6 on the inside, 2 on the outside. And 3 divided by 1. 3 on the inside, 1 on the outside. 3 goes into 9 3 times. No remainder. 2 goes into 6 3 times. No remainder. 1 goes into 3 3 times. No remainder. Our answer is 3 on each of those, so that means 3 times 3 is 9. 1 times 3 is 3. 2 times 3 is 6. That scale factor shows up on each one of those multiplications. Number 4, divide to find the scale factor. So first we're going to go ahead and match up the corresponding sides. Longest side of the rectangle matches up with the longest side of the rectangle. Even though that's on the left and that's on the bottom, they still match up. Shortest side matches up with shortest side. We have 2 different divisions to check here. First one, new shape, 3 divided by 6. Second one, 2 divided by 4. Now, here's where people are going to mess up. The new shape is smaller, so the smaller number goes inside. People don't like it when that happens because you wind up into decimal. Here's the trick. Just go ahead and add a .0 and then ignore the fact that there's a decimal there. 6 does not go into 3. 6 goes into 30 5 times, which is 30. No remainder, 0.5. 4 does not go into 2. 4 goes into 20 5 times, which is 20. No remainder, 0.5. If you do your division correctly, you will get a scale factor of 0.5. So that means 4 times 0.5 is 2. 6 times 0.5 is 3. All right, let's move on. Practice problems. We need to choose a pair of similar figures out of this group. Now, remember, similar figures is the same shape, different size. So as I'm looking at these shapes, some of them stick out like a sore thumb. V, there's no other parallelograms in there. These look kind of like the same, but they're shaped different, or they're laying down, whatever. U, well, that's out. Triangles, it looks like this one's a little too skinny to match up with that one and that one. So out of these, it looks like Z and U. Nope, we got rid of U. U and T. U and T. Nope, we got rid of U. X and Y, we got rid of X. Y and W, looks like those are the corresponding, or sorry, the similar shapes. Now, what was the scale factor for the figures in number 1? Well, that is 3 wide and 4 high. This is 6 wide and 8 high. So, 4 turns into 8. So I have 8 divided by 4 is 2, no remainder. Use your division, find the scale factor of 2. So that was 4 times 2 equals 8. All right. Find another pair of similar figures. Well, the only ones left are Z and T. So Z and T. What was the scale factor for the figures in number 2? Well, this is 2 tall by 3 wide, 4 wide by 1, 2, 3, 4, 5, 6 tall. Corresponding sides, I'm going to pick the longest side, so 6 divided by 3. So 6 in the box, 3 outside the box. 3 goes into 6 twice, which is 6. Subtract, you get 0, 2. All right. Explain how you found out which shapes were similar. Well, you look for shapes of the same size and, or sorry, same shape but different size. For shapes that are the same but different sizes. Okay, that's all there is to looking for similar shapes. Let's check back over the worksheet. Okay, This was lesson 2.2, talking about scale factor. We're going to learn how to calculate the scale factor. So we were going to calculate the scale factor for rectangles and triangles. Remember, this was your equation to find scale factor. We looked at our two examples here, a rectangle pair, a triangle pair, another triangle pair, another rectangle pair. Answered our questions by finding similar shapes out of the group. And this is the end of lesson 2.3 out of stretching and shrinking. Up next is lesson 3.1 in stretching and shrinking.